Welcome everybody to the New Year LARC January general meeting. We made it through 2020, everyone. Can you believe it?
Yes, indeed.
It is now in our rearview mirror as we tell it to kiss our behinds because it was really that bad. We look into the new year and hopefully things will improve. Just a little update in case people haven't heard. We got an email, I think it was last week. Currently, Boulder County is shut down to the end of March. Dick has had some ideas possibly for maybe an outdoor type event for LARC Fest this year. It's still in planning. But that's even the outdoors. So I don't know. I don't know if they're going to do the farmer's market. Well, farmer's market usually starts around April anyway, so they'll probably open up in time for farmer's market, but we'll have to wait and see how that goes for LARC Fest. So stand by. And if you're willing and you would like to help participate in LARC Fest, planning wise and other stuff, Dick would always love your help. So contact him. KE0VT. He's also got email on the club's website if you'd like to participate or give your 2 cents or try to help with that as well. We're always looking for volunteers. Other than that, the only other thing new is on as club members, you know that we have a Go Box, which is a portable radio system that was put together, and as a club member, you can sign it out and use it after you're trained on it and things like that. The club now has antennas for it. I purchased one of Ed Fong's J-pole, roll-up J-pole antennas for the UHF, VHF, and we did a Wolf River coil antenna. It's a vertical, very portable for the HF. It's 80 down to 6. So I'll be trying to tune it to make it a little bit easier for the box. And then hopefully when things start opening up, if you'd like to check it out and use it, we have an ICOM 7300 in it and a Kenwood 710G, and we also have a laptop with software for data that you can use as well. So the laptop has been updated as well. It's a lot lighter. Everything's in portable, 2 boxes, carries the entire Go kit. So we're ready for emergencies or just going out and activate a park or a summit or whatever. I don't think I'd climb this on a summit with this, but definitely could go to a park and do it. So we're looking at maybe doing that as well at some point this year, doing some on the air stuff with parks and getting more involved in the outside. So keep an eye out for that as well. I'm trying to think of what else is going on that everybody would like to know. Again, your board is working hard to keep the club going. I'm trying to put some fun activities together. One of the things I'm working on, if I can get it pulled off, is I'd like to do a fox hunt before the spring. And the fox hunt, I'm trying to do it a little bit different than a regular fox hunt. I'm looking at trying to do an SSTV fox hunt. So basically what it would do is have, whatever protocol I use would be the time that you hear the signal, but then you also get a picture of the surroundings to try to find it as well. So I'm in the process of trying to get that together. I'm working on a Raspberry Pi and a little Baofeng to make that happen, and we'll see how that goes. So keep an eye out again on the club website for any updates. And if you want to participate in that or help out, again, contact us. The board's always looking for volunteers to help with certain things and do projects or whatever. The other thing I was going to mention, nothing official yet, but a lot of people have piqued interest in possibly, and I don't know if we would do this on Thursday nights with our regular net or maybe have a separate net, but a lot of people have piqued interest on HF. I've had a couple of people approach me about doing a dedicated HF net that talks nothing but HF. So I'm thinking about that. I'll bring it up with the board, see what the thoughts are. I already have a couple people that are actually willing to be net controllers for that as well. So if you'd like to see that happen, we need a net controller. And I'm not looking for somebody to do net control the entire time like I do with my Hamlet net on Tuesday nights. but you know, we can alternate. To start out, I'm looking at maybe twice a month or once a month. We'll sit and talk about it and see what fits best, and then also find a night that doesn't already have 15 nets on it so people can participate. Other than that, does any of the board members have anything they'd like to bring up?
Yeah, Chuck, this is Mark. I've got just a couple things I want to put out. Okay, I just kind of wanted to point out, I know we've talked about, some different training, and there's, been some things on grounding and DMR and programming radios. And since we do work fairly close with RMHAM, they're also a nonprofit 501c3. We're using, the backbone and kind of affiliated. I just kind of want to put out that we do have a RMHAM University, and we've got we're also doing tech talks. You can go to rmham.org. They are free. You go under the RMHAM University. You can see the syllabus. You can look at some recordings. The last one that we had was on the big ones are on Saturday. The RMHAM U. The last one, James KI0KN from the Northern Colorado Club did one on batteries, probably more than you ever wanted to know, a lot of battery safety. I would recommend for those that didn't get a chance to see it, it is recorded. It is a very good presentation on batteries, battery safety, fire safety. I definitely recommend it. We've been doing tech talks on Tuesdays for an hour. I know we did one on the D710. We've done one on the chirp programming. That was last night. That recording may be up. We kind of had some audio difficulties, but I just kind of want to point it out. It's another option. I know on the 23rd, there's kind of a talk with WinLink versus P2P. Gary Stratton will be doing that. So I encourage you to check it out and see what's available. I know there's one on grounding that's coming up. And also if somebody has a presentation for, either a tech talk, which is an hour on a Tuesday, let me know and we can get you on the list. And then on the 13th, we call it Nerd Fest. And there is, I don't know all of the topics right now, but there's some pretty interesting ones. So I just kind of want to put a plug in. It's definitely some, some good experts with the with some training and some experience. Back to you, Chuck.
All right, thank you, Mark. And also with that, for those of you in DMR who may not have heard, Lee Hill is no longer doing the Brandmeister network. They're only doing the local Colorado talk groups, correct, Mark?
Yeah, the Lee Hill repeater is off. The one that was in Colorado Springs has it's actually on the RMHAM network, carrying the Rocky Mountain Wide and the South Talk group. There are also, if you're away from town and you can get in using Brandmeister and a hotspot, you can get into the North, Central, and South Talk group. Typically they're 721, 720, 719 locally is what you've got programmed in your radio. But there are 3 talk groups that Brandmeister forward to us that you can get into those 3 networks. The details are on the RMHAM webpage.
All right, thank you, Mark. Yeah, I just want to make sure because I know a lot of people were using Brandmeister or using Lee Hill for Brandmeister, and just let you know that's no longer available. So you either have to find another repeater that does Brandmeister locally or hotspot. So, and there's a few out there. I've been looking myself.
Yeah, it got very little use to justify the hardware.
Right. No, understood.
Hey, Chuck.
So, yes, sir.
How do we know when our dues are due? Since we haven't been in a meeting in a long time, I don't even remember when I paid last.
Our membership chair, Steve, will send you an email 30 days prior.
Okay, thanks.
he's on top of that. He likes to make sure the money rolls in. So, all right. Anything else from any other board member? Looks like Ed stepped away for a minute, so we'll floor is open.
Hey, Chuck, I've got a couple of things.
Yeah, go ahead, Brian.
Kat asked me to share that the January splatter is out. It's our monthly newsletter. If you didn't get a copy mailed to you for club members, it's available to members and non-members alike on our website, which is at w0eno.org. That's Whiskey Zero Echo November Oscar. We had a very successful VE session this past weekend in conjunction with the Patriot VE team. We tested 32 candidates, wound up with 12 brand new hams and a bunch of upgrades out of it. And one of the gentlemen was even on our Hamlet net last night. So we're still bringing people into the hobby, which is a good thing. If you hear any new call signs on the repeaters, be sure to answer them. It might be somebody trying to make their first call there. And that's all I had. Back to you, Chuck.
All right, thank you, Brian. And as a reminder, also Tuesday nights at 7 is the Hamlet net, and Thursday nights at 8 is the general Rag Chew net at 8 p.m. on Thursdays, which again, Jerry is always looking for people who would be net controller if you'd like to get out of your comfort zone and do that, or if you'd like to try the Tuesday night net. We're always looking for net controllers to help out and run those nets as well. That's a good way to get on the radio and practice your skills, especially like me who likes to hear himself talk. So anybody got anything else really quick? Otherwise, we'll go into the presentation.
Hey, Chuck, this is Steve.
Go ahead, Steve.
Hey, real quick, I heard the Hamlet Tuesday in the HF conversations sound pretty prominent. Along with HF, maybe we want to consider, you know, when you're looking at that, we can have talks around antennas, and then maybe the best type of HF gear that may be the most popular, maybe the first five top ones that that some of the generals and extra class have used for HF antennas. Back to you, Chuck.
All right, thanks. Yeah, again, it's still kind of in the planning phases. I do bring those topics up on occasions on the Hamlet net. I just don't want to get too in depth on that because again, it's for newer hams. I don't want to scare them off with all the technology and things like that. But that's why there's been some discussion about a dedicated either HF net or not quite sure how that's going to work out or look at it. Again, there's a lot of nets out there for all kinds of different topics, from puppies to veterans to children's with Bark Juniors have their own net as well. So I'm trying to find the best way to do this. So it's in, like I said, planning stages, but I'm glad that people have piqued interest, and that's what it's all about. This club belongs to you. Looking for ideas, and you know, we can't do everything, but we can see what we can do about getting some things accomplished and keeping people happy and educated out there. So anything else really quick before we let Ed take over and present for us? All right, Mr. Fung, the floor is yours, and welcome, and thank you for presenting this evening. Yes, sir.
You guys have seen the original dual band talk, right?
Dual band talk?
Yeah.
No. I don't think we've ever had a presentation from you.
Oh, okay, okay. But you guys put out the Splatter newsletter, right?
Correct.
Then there's another club that also calls their newsletter Splatter.
There might be.
Yeah, that's why. Okay.
Well,
But if you want the right talk, because
if you want ours, we'll send it to you. We'll be more than happy to add you to our mailing list. And
no, it's okay. I get plenty of newsletters. I got enough personal problems with the university. The things I got to read. Hey, people. I tell you, Chuck, people talk to me. My wife says, "Oh, haven't you read this novel?" Novel? Are you kidding? Last time I read a novel for pleasure, 40 years ago. I've got so much stuff I got to read for work and ham radio stuff and just keeping up with technology. So anyway, okay. Oh, cool. Then okay, this is the first talk. So, and yes, I have also, I noticed I have another talk, folks. Yeah. Folks were saying, if I actually have another talk that I have not presented on the internet yet, and it's the history of the walkie-talkie. So I've got another one. Anyway, so let's see how I do that. I go to share screen. I go like this, and I go like this. Ta-da, right? Share.
Yep, it's coming up.
And
There
it
we
is.
go. We can see it.
So okay, you can see it?
Yep.
Okay. And then I have to do this, right? Like that.
There you go. Yep.
There you go. Okay. Hey, great. Fantastic. Okay. Thank you very much, Chuck. So where are you guys located exactly?
We're in Longmont, Colorado, about 25 miles north of Denver.
Oh, okay. I know where that's at. National Semiconductor used to have a design center there. I think they still do. And
they might still have it in Longmont. I don't know. There's
yes,
a lot
and
of technology companies out here.
Yeah, and it got bought out by, no, it was originally the, it was bought out by National Semiconductor. Of course, now it's part of TI. So there's a TI design center still there?
I'm not sure. I don't, if there is, it's not a big building.
Yeah, it's not big. I used to have like 8 folks there.
Yeah, the biggest technology company. I mean, we got lots of small mom and pop technology companies out here in the Boulder, Longmont area. I'm currently working for one, Xilinx, which does FPGAs.
Oh, sure.
Field
Xilinx is actually just down the road from me.
Yeah. Oh, in San Jose. Yeah, I've been to the main
in
campus.
San Jose. I hop on 85, and there it is. And I get a lot of students that go to Xilinx.
Oh, yeah. Well, it's a great company.
Oh, it's amazing what they've done. Amazing. So very good. That's a good company to work for. I've heard good things about them. And of course, I've seen a lot. I teach a lot of the circuits you guys do in your FPGA, and I use a lot of your FPGAs. So anyway, and yeah, you guys make some great ones. I'm just amazed how you guys can do it. Anyway, let's get started here. So good evening here, and thanks a lot for Chuck for inviting me. This is the first of about 4 or 5 talks I can give on ham radio topics. So if you guys need a talk, I'm scheduled out. I try to give 2 ham talks a month at most because my university job is pretty heavy. So I try to give at least 2. So right now, actually, my signups are because of COVID. Everyone wants a Zoom talk. So I'm way out into fall. I'm signing up for like October, November. I am pretty filled up. So anyway, let's start this one. You haven't seen this one yet. So the talk I'm going to give tonight was on my original, this is your first talk. So this is the original dual band J-pole we came up with, 2003. I'm going to make sure I have the right mic here. You guys hear me well?
Yep, loud and clear.
Okay, because I like my USB studio mic. It just sounds a lot better than the one that's on the camera. Okay, so the talk I'm going to give tonight, it's been covered in, it's in the VHF, UHF Antenna Classics, ARRL. It's in the Volume 8 Compendium, Volume 3, but it was originally published back in February, back in 2003. So almost coming up on 20 years. So it's a pretty well-known design, but it's a good introductory. And then I've got subsequent modifications to it that we can give you from portable to tri-banding and things like that. And here are the articles. The one on the right is the original title page. The one on the left is the roll-up version we came up with like 4 or 5 years later. That's very popular. Then our latest one is our tri-band version of it. Covers 2 meters, 220, and 70 centimeters. That's another talk we can give. That's a very popular talk now with a lot of folks getting on 220. It still all fits in one PVC pipe. That's my daughter there. At the time, she was an undergrad student. Now she's a graduate student finishing her master's in mechanical engineering and electrical engineering. So she's a double major. It's amazing what she'll have a master's in EE, but she talks to me and she says, Dad, they don't teach any of this stuff in my school. She knows all this math. I'm sure a lot of guys, you guys are EEs. It's amazing. You can go through a master's these days and you come out, then you start learning the practical stuff. I mean, I can talk to her about Fourier transforms, discrete Fourier transforms and all this stuff, eigenvalues. She knows all that, but circuits, she goes, well, we kind of have this. So I wish they would teach more circuits. I know at our school, I really try to emphasize practicing engineering. But anyway, she's doing fine. Let's see. So, and we've had to patent some of our ideas, not by choice. We had to patent it because people were copying it. So we have 2 patents on our antennas, our tri-band one. We did not patent the original dual band one. I just didn't know until we started finding people copying it. And that was okay. I didn't mind. That means, they say copying is the best flattery. but they start selling it. That's what I didn't like. In fact, I didn't even mind clubs doing it as a club project for new hams or even old hams to work on weekends, do a club project. It didn't bother me. But when they started selling them on eBay, I said, wait a moment, that's my design. And then I started buying them. My fellow faculty member, Ron Kwong, said, hey, let's go buy these, see how they are. They were lousy. They didn't even do it right. And that's bad. You know, when they would say, this is the Ed Fong antenna, and you're buying it from me and with a certain cost. And so we bought these, and they weren't even good copies. So that's when I talked to our attorneys at the university. Said, no, you got to patent this stuff. So it was too late to patent the first one. So subsequently, we have patented things. And the good thing about patents, you guys can read all about and figure it out. Okay, so we start out, the goal here is to make a good dual band antenna. We started out with a J-pole, and I'll give you a little history behind the J-pole. I like the J-pole, and you'll find it very popular. Right? I'll bet you most of you guys use J-pole antennas, you know, compared to the ground plane stuff. When I grew up back in the 60s, ground plane was a very popular antenna. Oh, by the way, questions we should just wait until later, because the way how Zoom works, it's easier to have questions in the end. So just make notes and we'll have time for questions and answers. But I used to use ground planes. I bet a lot of guys, you guys use ground planes too. And they worked. You know, I didn't know a whole lot about antennas. You get an SWR meter. Hey, it works fine. But it turns out it's not a very efficient antenna. And that's why you see J-poles a lot now. And I'll get into why. You know, well, one is when you have ground planes, you have things sticking out. That's not good for an antenna. Things that stick out cause a wind load. And if you're going to put it on top of a mountain with snowstorms and wind and all this, it just falls apart after a while. Another thing about a J-pole is actually it has a very good pattern, better than a ground plane. You know, you'll think ground plane isn't an omnidirectional pattern. It is, but it's got a little higher angle of radiation, and we'll get into that later on, explain why. So I like the J-pole. It actually gives you about 1.5 to 1.6 dB higher gain because of its angle of radiation in a ground plane. So that's why you really don't see ground planes that often. That's very rare these days. It's also end-fed. You know, a J-pole is end-fed, a ground plane, it's kind of bottom-fed. Let's see, did I cover this other? Let's see. Oh, here. The other thing about a J-pole is we'll see, it's a DC short, and that's really critical. If you put a DC meter across it, it reads 0 ohms or half ohm or so, which means that at DC or at most frequencies, it just shorts out. So it can't build up charge. It's always grounding out to the shield, you know, ground, because it's a DC short. A ground plane and a dipole are not that. They're open circuits. And that makes it very vulnerable to lightning. You know, a nearby lightning, you'll induce it like a transformer. And if you induce, you know, more than 30, 40 volts, usually your front end goes. And we used to lose front ends like crazy. And that's why you buy a lightning arrestor for another 50, 60 bucks. Commercial grade ones are about 100. That's another thing good about J-pole. It does not, if anyone's going to sell you a lightning arrestor and you say you're using a J-pole, they don't know what they're talking about. You do not need a lightning arrestor for a J-pole configuration. It's a DC short. You can't get better than that, right? It's a DC short. It's always discharging. So here's an interesting photo. I took this a few years ago up at Mount Sutro, which is the local super hill here for all the antennas for FM and two-way radio communications and all that. So you notice there's not a single ground plane in here. They're all, it appears like they're all kind of a J-pole configuration because they don't have ground radios. Typically, if they don't, that means it's a J-pole, which means they don't require a lightning arrestor. It's a DC short. But you know, if I had taken this picture 20 years ago, you would have seen a lot of ground planes. So pretty much the vertical J-pole has taken over. Now, a vertical J-pole is 3/4 of a wavelength tall, so that is a disadvantage. You know, ground plane is only 1/4 of a wave, but then it has radials. So if you look at it, but overall, people would prefer just to end feed an antenna from the bottom. And even though it's a little taller, that's okay. There's plenty of room here. I mean, it wouldn't be good for like a 20-meter HF antenna, but for VHF, UHF, there's plenty of room vertical for the antenna. See, here's a dipole mounted. Here's a dipole actually mounted on the side of a house. But you get the general idea. A dipole is an open circuit. One end goes up there, one end goes down there. You put a DC meter across it, it reads infinity. That's a good dipole, would not be a short. You would need a lightning arrestor for it. because, you know, if this induces some lightning storm or something, if there's a lightning storm close by, you might induce 20, 30, 40 volts. There goes your front end. And I did volunteer work for the Red Cross. I still do. Oh, they used to blow out more front ends because, again, in the same roof, they've got their Red Cross radio, 60-watt radio, other HF radios, a kilowatt, in fact, with a linear. The reliability of radios there was just terrible. The front ends would always go. That's because the antenna will induce a voltage because it's open circuit, even though it's not resonant. And then if it's more than 20, 30 volts, the front end goes. And see, the other problem with a dipole, why people don't use dipoles here, is you got to feed it in the center. It's a vertical quarter wave up, vertical quarter wave down, and you got to feed it 90 degrees. Well, that's pretty cumbersome compared to end-fed. You know, we'll get into this, an end-fed J-pole. This is really inconvenient. Plus, if you notice, it torques it. The further out you go from the mast, you know, you got to put that means you have to have a mask also. So you got to push it out in the mast because of the coax. The more torque, right? If you're a mechanical engineer, you know, it's R cross F. The more this further goes out, the more torque you get. That's bad. If you're up on on a mountain where the winds get high, in the winter the snow gets there, eventually you'll stress that arm and it'll break. A J-pole doesn't have that problem. So again, we'll get into more details of the J-pole, but again, I was first introduced to this antenna by Denny Monticelli, AE6C. I worked with him at National Semiconductor back 30 years ago, and he said, "Hey, check this out." I didn't know much about J-poles. We were in ground planes, and you know, you would buy commercial old with diamond. Well, they didn't have diamond, but Hustlers and all those high gain. They were all based, or virtually all of them were based on a ground plane, and then they built it on that. But here's this J-pole, DC short, and you wonder, how does that work? It's a DC short. It's not a short at 150 megahertz at 2 meters. It's 50 ohms, of course. I always teach that to my students. Don't get confused between DC resistance and impedance. Impedance is an AC impedance, AC resistance, and while resistance is usually a DC term, if it's AC, it's called impedance. So you don't confuse the two, because like an antenna, it could be a DC short or DC open, but its impedance has to be associated with a particular frequency. Like a 2-meter antenna, at 2 meters, it would be 50 ohms. Everywhere else, it can be anything. But you would like it to be a DC short, because then it discharges all the time. So I saw this antenna. I go pretty simple. Again, 3/4 of a wavelength tall. This is on 2 meters, so it's about 60 inches. So much taller than a ground plane, but no radios. I went home and tried it out, and hey, it worked well. I could tell it was a very good functioning antenna. And at the time, it was just made of Radio Shack cheap twin lead. And I said, yeah, for something this simple, it's not bad. And I thought about, hey, if you put this thing in a PVC pipe, this concept, this would be a great antenna. And so, yeah, we did that. And that number is totally obsolete. We have sold our dual band J-pole versions of it, both commercially and for hams, about 30,000. So we sold a lot. Let's see. Okay. So that was a single band one introduced, and I'll get into in detail how we look at it. But what this presentation is about is how do you make it dual band? Because by time mid 90s, late 90s came along, we all had dual band handhelds, dual band mobiles were coming out. And a lot of folks didn't want to go out and buy a dual band antenna for 100, 150 bucks. Is there any way you can convert a J-pole, also have it dual band? Well, the thing that's interesting is people notice, but mine kind of works. My J, they had J-pole designs, the copper J, we'll get into later. They would buy this copper J, and then there's some other versions of it, this twin lead J, all basically, it's a J-pole. They notice it kind of works on UHF, and the key word is kind of works. When you actually measure it, you measure the SWR, that's okay, it resonates. Resonating is not the problem. But what happens is you see there's about a 6 to 8 dB loss. 6 to 8 dB loss compared to a quarter wave or a half wave dipole or a quarter wave ground plane. About 6 to 8 dB loss. That's quite a bit. That's why you notice it. Folks start saying, yeah, it works, good SWR, but it doesn't seem to work just right. And we'll explain that in a while. So the goal here was, could we make a J-pole, standard a single band VHF J-pole, also cover UHF ham band without this typical 6 to 8 dB loss? And what's interesting about it is because a lot of folks say, hey, we got these J-poles, but they don't work very well at UHF. They can hit a repeater maybe, but they don't work very well overall simplex, because again, 6 to 8 dB loss is quite a bit. That's 75%. And so I went out thinking, well, first of all, let's figure out why does it lose 6 to 8 dB, and then we'll see if we can figure it out. And the other constraint of this additional design that we would add the UHF into this 2-meter antenna, it was going to go to hands. It couldn't be something elaborate. Pretty simple, had to be reproducible, nothing fancy, and yet it had to work. So that's always a difficult requirement, to make it simple. So yeah, we figured if I can come up with a solution to make a 2-meter J-pole, also cover UHF, but not lose a 6 to 8 dB, it couldn't have any fancy inductors or fancy capacitors, because one thing, they're hard to obtain and they're not easily reproduced. If you go look at a typical chip cap, if you really look at the specs at 500 megahertz, you go look at some of these people that make these caps. Oh, their specs are like 10%, and plus they vary with temperature. So if you're going to do anything up at VHF, UHF, and maybe VHF, you should really, if it's related to antennas, try to avoid commercial capacitors, because they vary like crazy, they age, they get oxidized, and it's not very reliable. And the same goes for if you see an antenna. If you ever buy an antenna and you take it apart, wow, this thing got a bunch of capacitors in there. Forget it. Over time, that's not a good design. A good design should not have capacitors in there, not in an antenna. So I tried all kinds of configurations, and I'm going to present them to you and tell you what works. So here's the problem. Here's a Smith chart. What this shows is if you simulate a halfway vertical, that's what a J-pole is, halfway vertical. It's called a J because of its matching, and I'll get into why it needs that matching. But typical half-wave dipole, a really ideal dipole in free space. At the fundamental will look like this. We expect that, right? That's the, looking at it, this is called the elevation plot. So this is looking into it where the top is the sky, the bottom is the earth. Or you can say that's north and that's south. The pattern would be, in its fundamental, this is very familiar, figure 8 pattern. And so if you're looking at it from the top, it's 360 degrees, but kind of flat. Now, if you look at it from the third harmonic, which in our case would be UHF, then the pattern's not so good. It forms lobes. So here's Earth, here's the sky, here's the bottom. So here's your transmitter, you're standing right here somewhere. And on 2 meters, it works fine because here's the lobe, the figure 8 lobe. But on UHF, it's not so good. At UHF, here's the lobe, and most of the energy is going up 45 degrees up into the sky. So you're only left with about 25% of the energy if you were to integrate this whole area, which means that's equivalently 6 dB loss. So most of the energy is going into the sky, 75% of it. And that would be okay if you're talking to a satellite or talking to the International Space Station, or if you're talking to an aircraft or something like that at the third harmonic. But not okay if you're talking to someone else on Earth or a repeater or something. You want a nice pattern like this, where most of your energy, the peak of the energy is right at the horizontal line right here, which is Earth right here. You want it like that. So how do we get this big lobe looking like this at also UHF? So I'm not going to go through the Smith chart, but just review what we need to know for this antenna design. Here's a Smith chart. That's 0 ohms. And then a Smith chart represents, if you go 180 degrees, it represents 1/4 wave. And then that's infinity. So all we have to do is interpret in this talk is that if you have a short circuit at a 1/4 wave, it'll be an open circuit. And if it's an open circuit, it'll be a short circuit. So I can get a stub here and I'll show you. Let me get a stub here. Here, got some left. But by the way, just can't see all of you right now, but how many of you guys got one of these cool little gadgets here? Nano VNAs, just raise your hand. Yeah, they're really nice. You know, for 50, 60 bucks, they are really handy to have. It displays the Smith chart. It's an AC impedance meter, or known as a network analyzer. It will show you the impedance at any given frequency. So again, what the Smith chart shows you is if you have a little piece of coax, this is about 5 inches here, pretty close to UHF. At UHF, what it says is if I short one end and go a quarter wave, it will be an open. So that's hard to believe. You know, if you get like new graduate students or not RF people, they say, wait a moment, if you short one end, it's a short on the other end. No, it isn't. You're thinking DC. DC, it's a short. But at a quarter wave, it's an open or infinity. And what the Smith chart also shows you is if you open one end, right, it's infinity, let's say open circuit. If you go 1/4 of a wavelength, with the UHF would be about 5, 6 inches, it would be a short. So that's one way that you have to think differently. If you're an RF engineer, you're coming from just a basic, you know, low frequency EE background. You have to know how waves work. So we review that. So here's how the J-pole works. So again, in a basic J-pole, not the dual band one, here's a half wave. Here's a twin. This is just twin lead, so you really don't need this. There's a twin lead. There's 2 of them. So electrically, you don't need that, but it's there because it's twin lead. So here's a half wave, about 37, 38 inches. That's a half wave dipole. If it were a dipole, you would have fed it in the middle. You would have fit it in the middle because the middle of a dipole is 60 to 70 ohms in that range, which is great because our coax and our radios are 50 ohms, and that's a pretty good match actually. 1.5, 1.4 to 1. You can feed it right angles, but you would have to feed it at right angles. You cannot have the coax close by and parallel. You'll screw up the impedance. You have to have it out at right angles coming out here. And you got to really come out reasonably a couple of feet. Otherwise, you'll interfere with it. And then the other problem is then you have to have a mass to hold it. And the further you have it out away from the mass, the more torque you have. And then over time, it will just break off. So although electrically, that's a pretty good antenna, physically, it's a very tough one. And plus, you know, if you had the mask, obviously, if you had the mask here and it was metal, that would be even worse. It would act as a reflector. And besides, that coax has to run down somewhere. If you run it parallel, that's bad. It will couple with that antenna. So a vertical dipole is not a very good antenna if you feed it from the middle. It's just got too many problems. You know, you even will feed it right angles. At some point, you got to come down, right? At some point, if you do come down, that will act as a reflector and it really screws up patterns. So we go to the vertical J-pole. So you got to know what the characteristics of a dipole are. It's low impedance in the middle, 60, 70 ohms. If you bend it, it goes down a little lower. But as you go towards the end where it starts radiating, the impedance goes higher and higher and higher. In fact, ideally, you know, it should be infinity. It's never infinity because of air and everything. It's in thousands of ohms, maybe a couple of 1,000, 2,000 ohms, high, much higher than here. Well, if you can feed it at the end much higher, then you can go down from that piece like this and then have the coax at the bottom, end fed, or known as end fed. Because when you end fed, it's very convenient. Even at 20 meters, you can have an end fed antenna. You just throw one end way up in the tree and you're done. You don't have to center feed it. We'll use the same principle here. So this needs to be high impedance. The ends of a dipole are high impedance. How do you match a high impedance to high impedance? From 50 ohms, right? We have a radio that's 50 ohms, but we got to get it high to end feed an antenna. Otherwise, we're stuck with center feeding it at 50, 60 ohms. So that quarter wave stub thing comes in. If it's a short on one end, if you go up a quarter wave, according to the Smith chart, it will be a high impedance. Smith chart says infinity. It probably won't be infinity, several thousands ohms. Infinity is really a hard number to grasp, but it's high, very high. So it's a short circuit 0 to here it's not infinity, but very, very high. That will match right into that high impedance point there. And then since it's a short circuit here, got to be 0 ohms. And the way you feed it is, if this is 0 and this is infinity, it's got to be 50 somewhere. In fact, common sense will tell you 50 is a lot closer to a short than to infinity. Sure enough, it is. You find that tap either on a network analyzer, obviously you can simulate it, but let's say just by experiment, it's about 1 to 1 1/4 inch, depending on the material. You'll find that short turns into 50 ohms. So great, you could feed it with 50 ohms, a short circuit, and by the time it marches up there, it's going to be a couple of thousand ohms that matches right into the antenna. And that's how you get a vertical J-pole to work. Now, so here's some pretty interesting examples of them. Here's the copper J, which I'm sure a lot of you folks have. I have one. In fact, I have one right here. Here. We buy all these, or we either buy them or we make them. This one I think I actually bought. We wanted to check it out. We wanted to check out its great matching system. I don't necessarily recommend a copper J these days. Even to build one's pretty expensive. The copper pipe is not cheap anymore, but it's pretty clever. You know, from I saw these, you know, in the 1990s. It's a pretty clever design. Again, here's the half wave part. Here's the short. And then sure enough, about 1, 2 inches up, you get the 50 ohms, and that's how they tap it. And this antenna works. I mean, I know the one I have here seems to work okay at 2 meters, but going to 70 centimeters or UHF, it doesn't work so well at UHF for several reasons. By the way, the reason why it resonates antennas at UHF from 2 meter for a 2 meter antenna, if you get into details of antenna design, if you make one at a fundamental, let's say 100 megahertz, it will resonate always at its odd harmonics. That is, it will resonate 100 megahertz antenna will resonate at 300, 500, 700, 900, etc., all at odd. So that means if you make an antenna for 140, 155, it will resonate at UHF 440 to 450. Again, but it shows that pattern I gave before. It's the wrong pattern. It will resonate, but it won't work that well. But this one also suffers another problem at UHF. It's just you're using this transmission line here. That's the transmission line that goes from 0 and then you can go to infinity up here. One of the problems is it's an okay transmission line at VHF, but at UHF, a quarter wave is only 5 to 6 inches. And you're kind of limited here by the plumbing. The T takes up some space, the elbow takes up a space. And by the time you build this thing, between the actual center and the J part is almost approaching 2 inches. And so you cannot approach 2 inches here and expect it to work at UHF, because UHF quarter wave is only 5.5 inches. So there's just too much of a mismatch. It starts radiating here and there's just too much of a mismatch. So I don't think anyone claims that this antenna will work at UHF because of the matching ability of it. Because again, this is the transmission line here that converts the 0 ohms to infinity. Well, you have to assume that that's a transmission line. Well, this isn't going to be a very good transmission line at UHF because it's already 2 inches, and a quarter wave at UHF is 5 inches. It's got to be like twin lead, quarter inch will make a good transmission line. So this one works for 2 meters, but not well for UHF. Another interesting design is the arrow design we looked at, and it's a pretty popular design. We own one of these too, right here. And we try to take apart a lot of these antennas. So that's the arrow, and really try to characterize them. Do they really work? Do they work as they claim? That's just kind of part of my job at school, just trying to figure out things like this. And the students love it. We measure things, and I always tell them, see, don't believe everything you read, especially ham material. Commercial material is okay. I think ham material, boy, you got to be very careful about, especially with antennas and gain. Now, what we found with this antenna, again, this is, here's the 2 meter portion, 57.5 inches. And then here's the J part for the 19.25 inch. And then at UHF, here's the UHF part. Here's the 6.5 inch J part for the matching. And then here's the actual radiating part. So that's a pretty clever twist on trying to get dual band out of it. They added an extra UHF section, and they actually feed it in the bottom in parallel. So we found this actually was a reasonable antenna. At 2 meters, it was reasonable. And even at UHF, it was reasonable, but not completely optimum, because the reason why is you would feed the UHF signal into this antenna. And yes, you had the right antenna. The UHF is this 6.5-inch piece and this 19.25-inch piece. But since it was the same connector, remember the VHF antenna will still resonate at the third harmonic. So we found about half the power was going at UHF going into the wrong one here, and half the power was going into the right one. But that's not bad. That means 50% of it's going into the right one, and the other 50% that's going into the wrong one, you're losing 75% of that. So it's still quite an improvement over just feeding a UHF signal into a J-pole. So that's pretty clever. And then there's another antenna you hear around called the Slim Jim, which is really basically a J-pole. The only thing I have to say to that is don't believe it when they say it gives 6 dB of gain. It's just a simple J-pole. You can simulate it. We've built models, and nothing wrong with the Slim Jim. It won't work at UHF. 2 meters, it's fine. It's not 6 dB gain. It works pretty much just like a regular J-pole. Okay, so let's move on. How do we dual band this? This is how we did it. In the end, fairly simple. Again, here's the matching stub. 0 ohms, 50 ohms. And you come all the way up here, it's high impedance. And for 2 meters. But it's also high impedance for UHF. And it's a very simple way of explaining why it's high impedance. It goes after an extra half wave. This is a quarter wave. It's a quarter wave at 2 meters. It's a 3/4 wave. It adds an extra half wave of distance. And remember, if you guys are into the Smith chart, for every half wave you add, you come back to the same impedance point. That's why any given antenna, you add a half wave, it comes back out to the same impedance point. That's another way of translating and saying, if you get an antenna working at every odd order harmonic, which is adding on a half wave, you will get a resonance. Not a good working antenna, just resonance. So for the matching, that's not a problem. We're just trying to match here. We're trying to match here 2 meters and also UHF. We can use the same stub. Matching is not the problem. The problem is once the wave escapes here, it's high impedance, it's got to go into something. It's got to start radiating as an antenna. Well, at UHF, if it went to 11 or 12 inches, that is a half wave at UHF. It would be fine. If it wasn't for all this stuff, just you cut it off right here. It will work well as a UHF antenna. It won't work as a VHF because at VHF, it wants to see about 36, 37, 38 inches, depending on what frequency you're on. So add all this up, 17, 4 1/4, and 11 1/4. It's like 37 something. So the whole thing is a half wave radiator for 2 meters. But what you want at UHF, you don't want this whole thing at UHF. The reason why is you want it to cut off right here. You want a half wave signal to appear this half wave vertical dipole at UHF and cut it off. You don't want any of this stuff on top. If you did, which is a normal antenna, well, the currents will continue. The currents will continue, and that's what creates those lobes that are pushing up that wave. The currents will continue. You want to cut off. And if you cut it off, cut all this to the 17-inch, and you cut off this 4 1/4 inch, you would get that half wave at UHF. So what we did was you have to electrically cut it off. You can't physically cut it off. You physically cut it off, it won't work at 2 meters. So you got to electrically cut it off at UHF. And again, back to this stub thing. If it's a quarter wave short at UHF, you go down here, it's going to be an open circuit at UHF, because we showed that in the Smith chart. And you say, why is it 4 1/4 inches and not about 5.5 to 6 inches? And that's because we're using coax with a velocity factor, right? That 5, 6 inches comes about from the formula speed of light is equal to F lambda. The speed of light is equal to frequency times wavelength. In air, there you see 3 × 10⁸ meters a second. But speed of light in air is the fastest you'll go. Anytime you put a wave in a medium, in a dielectric, in coax, in water, water has a velocity factor of 0.5. which says that when you put a radio wave into water, all of a sudden it slows it down by 50%. Well, if you put it into coax like RG174, it has a velocity factor of like 0.66. So it slows it down by 33% or so in thereabouts. So therefore, you have to cut the length because C is equal to F lambda. You can no longer use 3 times 10 to the 8th meters a second. You have to use like a little bit more than half, about 1.8 times 10 to the 8th meters a second. And if you calculate that for the length of coax, then it's about a quarter wave is about 4 1/4 to 4 1/2 inches to get it to resonate. So what happens is at 4 1/4 inches with RG174 coax, there's a short hair that presents a high impedance or an open circuit to that wave at UHF. So sure enough, it will stop. The wave at UHF, remember the matching was fine here. You excite this with a UHF wave, it will see this strictly as a half wave, a vertical radiator, and all the rest electrically would disappear. But now that stub is only resonant for a quarter wave at UHF. It's not resonant throughout. At VHF, the wave goes through, it's not resonant anymore. So that's how it works. That's how you get to, it knows whether you put a VHF wave signal or UHF. Here's a portable version of it. It's the same way. One of my students actually came up with this, putting it with a RG174, the BNC connector, all the same. He figured out a really cool way of twinning how to do these cuts that will still support itself, and then you kind of bypass the RG174 cable. So fundamentally, it's the same. So yeah, you notice the dimensions are going to be different. So this one here is the one that operates in air. You kind of hang it up. You can roll up this thing and put it in a little plastic bag. While this one here, this one here was designed to go into a PVC pipe. Now, the PVC pipe certainly doesn't speed up the speed of light. Nothing speeds up the speed of light that we know of. It's got to slow it down. So when you put this antenna into a PVC pipe, it turns out that it loses about 2 to 3% of its speed. Now, don't confuse this with, a lot of people confuse this with losses. No, there's no losses. There are very little losses. It's just the wavelength. It changes the wavelength. As you cover an antenna with certain material, in water, for instance, it's about 50%. The velocity factor of water is about 50%. So you could say it slows it down by 50%, or another way of saying the wavelength will change, right? If you slow down the speed of light, C is equal to F lambda. Speed of light is always equal to frequency times the wavelength. So in water, the frequency has to stay the same. But if you're going to make an antenna, it's got to be about half the size to be resonant, because water slows down the speed of light by about 50%. So in this case, the PVC pipe slows it down by, I don't know, 3 to 5% or so. And you notice if you add up all these dimensions, and if you took our roll up and our base, and the base is designed to work inside the PVC pipe while the roll up is designed to work outside with no covering, you'll find that it's about 2 inches difference. You line them up side by side, 2 inches difference. And then another frequent question that comes up is, what about this PVC pipe? Yeah, we use to cover up the antenna. So if you didn't cover it up and you left it out in the elements, 1 or 2 seasons, especially in the Midwest, and it'll be gone. So you got to cover it up. And I found that PVC pipe Lowell's 23990 really works quite well. How do I test it to see whether it works quite well? It radiates well, but even a simpler test is this. You cut a piece, you put it in a microwave oven for 5 minutes or so, and it does not turn warm, which means it has virtually no metallic elements and no organic elements in it, because it doesn't turn warm, which means it doesn't absorb much RF. So, and Lowell's pipe is pretty inexpensive, 10 feet for about $250. And it's RF covering a radome, it works quite well. So here's a test on this antenna. So the main thing we're trying to emphasize is, can we make a 2-meter antenna also perform well at UHF? And what we've done is we're saying you can by putting this decoupling stub, a quarter wave decoupling stub, at 12 inches up from a J-pole, which is a half wave for UHF, and then you cut it out. Well, does it actually work? Well, here's a 2-meter standard J-pole, and we put a UHF signal on it. This is just a reference. This is on an HP spectrum analyzer. I believe those are old 8591. But surprisingly, you can buy spectrum analyzers now real cheap from China. I don't know how accurate they are, but they're certainly pretty cheap. But this is a pretty expensive one. I think it's about a $22,000 piece of equipment. So there's a reference, 2-meter J-pole, but used at UHF. And then if I use the same point, and by the way, we just did this, nothing real fancy, in a parking lot on a weekend where there was no cars, spectrum analyzer, we did some tests like 50 yards away. And sure enough, when you use our antenna with that little stub at UHF, which stops the wave from continuing, which then causes these lobes going up into the sky, about 75% of that energy goes up in the sky. If you put that little stub I was just talking about, you get about 6 dB gain back. It really does work. And a lot of people have tried it, and yes, it does work. Simple, reproducible. You can do it if you're with a good antenna analyzer, or even if you're really patient with a good SWR meter, you can build one. Just starting with our dimensions. Now, what you can't do is just copy our dimensions. Not that I don't care if you copy it, but it won't work. Usually because the twin lead has a different velocity factor. The coax does. And what you got to do is you got to tweak it. And in our paper, we show you how you take each measurement. It helps to have an analyzer or an organalyzer. Okay, so we did performance tests on this. And why do I have time to do performance tests on this? I don't have time to do performance tests. You give it to you. This is a whole thesis one of my students did about 5 or 6 years ago on how to measure antennas. It's really complex how to measure antennas. And to make a long story short, you should be measuring at 3 different days of different weather factors, and also for each day measured at least 5 times, and then take the average. And of course, throw out all the erroneous data and all this, statistically you can figure out what are the relevant measurements. So this is an average of 15 measurements. What this top shows is, here's the reference of just a quarter wave mobile antenna, in fact. It's relative 24.7. We compared it to a rubber duck, and it was just like 50 yards away. And sure enough, 24.7, you get a rubber duck, you lose almost 6 dB, minus 30.5. So it's about 6 dB off, which is consistent with what people tell you. Standard J-pole gives a little bit of gain. It's not a tremendous amount of gain over a ground plane, but it is 1 to 1 by 1.5 dB. Not significant, but you could hear it. In a weak signal, you should be able to hear it. You can certainly measure it on test equipment. And our dual band J-pole, a little bit inferior over the standard J-pole. I think it's because that stub, you lose a little bit, not much, 0.1 dB, right? It's minus 23.34. This is minus 23.47. 0.1 dB, that's not significant. So when you use our antenna, it does lose about 0.1 dB at VHF. But what you gain is the UHF. Here's the UHF down here. Reference quarter wave, 38.8 dB. And use a rubber duck UHF. They work quite well. It's only about 3 dB loss. In fact, if you are particular and get the right one, matching it up with the right handy talkie with the right ground plane, because these rubber ducks at UHF, they're 4 or 5 inches tall or long. That's very close to quarter wave. So they actually work quite well. In fact, if you are particular about it, you can probably find one that matches your HT really well, and you probably get maybe no loss. I've played around with it since. Yeah. If you're really careful, you can get a pretty good rubber duck working at UHF compared to a quarter wave ground plane. Now the standard J-pole, if you use a standard VHF J-pole, but now you're at UHF, it's terrible. You can measure it. Our reference is minus 38.8. You put that standard J-pole at UHF, it's down to minus 45 dBs. Oh, that you'll notice. That wouldn't take fancy measuring equipment. It's losing 6 to 7 dBs. That's a lot. Unless you're listening to a strong repeater, it's a lot. And then when we use our J-pole with that little decoupling little element, that quarter wave decoupling, it comes almost right back. Instead of 38.8, it's minus 38.9. So here you lose about 0.1 dB over a regular J-pole. You lose about 0.1 dB over a ground plane. But not bad. Compared to 6 dBs, that's really, really good. That you will hear the difference. So here's how we did our original tests. I don't even use my 8753 as much anymore. It's a good instrument, but boy, you get one of these nanos, and I tell you, for this one goes up to 1.5 gigs. For all the measurements I need, it's fine. It's portable too. A lot cheaper if you blow it out. And here we go. Here's so I wanted to look at that stub, that quarter wave stub. That's the trick here, right? You need that quarter wave stub. I measured it on our 8753, which is the network analyzer you saw. And, at 445, there's not infinity. I didn't expect this, If you short one end, it's not infinity, but it is really high, right? I mean, this is a short, that's 50 ohms. This is a log scale. And you're sitting somewhere around there. It's not infinity, but it's pretty high compared to 50 ohms. And maybe that's why it's that 0.1 dB loss. It's not perfect, but it's certainly night and day difference. And I looked at that stub, and I see, well, how stable is it? You know, if you cover it with PVC pipe, if you put your hand around it. So I played around with it, put my hands around it. Yeah, it fluctuates in its impedance, but not at 445 where it resonates. It's pretty stable. So I'm pretty confident it's pretty stable as a 445 quarter wave stub, which means it's short on one end, open on the other end, because you want that to decouple the rest of the antenna at 445. And then the other question a lot of people ask, well, how about the 146 megahertz shorted stub? How does it look? Well, at 146, it kind of looks like here, what, 146, pretty close to infinity. Looks like a piece of wire in air, very close to it. Oh, and here's the open wire, right about there. It's close enough to a wire, I think. You know what they say, good enough for government work? Yeah, we've sold a lot of these at government. They haven't complained yet. So here's how it is. Here's how it's mounted. See, again, it's tall. It's tall. It's about 60 inches. But no radials, plus it's end fed. That makes it really convenient. You don't have a tower. You don't need a mask. It's those things are a mess. So it lasts really long because the weight is just vertical. And of course some wind, but it's vertical weight. You don't have anything torqued or arc cross F. So here's the portable version we have. That's the antenna itself. We have a 6 feet RF extension that we had Maya cables make up. And then when we sell these, or when my students sell these as a package, it's a BNC, but then we include the adapters BNC to S male, and then you can go to SMA female for the Baofengs. Also, we will include that 6 feet extension cable, and you can buy more too, if you like. Oh, so here's some other talk. I didn't lose you. It's okay, so I can see some of you guys. Was this talk at your level, or is it too advanced or too elementary?
I think it was all over for everybody, but I mean, for me, it was a little bit advanced, but I enjoyed it because I've been trying to learn more of that. And like you said, we have some, you know, engineers here who probably is like, oh yeah, I knew all this already. And others are like, hey, this is interesting. So
Okay.
I personally enjoyed it.
Yeah, it's tough for a ham club.
It can be, but you know, again, I've got your right here. We bought one for the club. Yep.
Yeah.
We're using that with our Go box because it's nice and portable. And I have your tri-band.
It's portable and it works.
And I have your tri-band. I had to take it down.
Do?
Yeah. I bought it about 3 years ago when I got into the hobby. And it was outside for the longest time,
really?
But the connector came loose on the bottom, so I had to resolder it, and I got it. I just haven't hung it
Yeah,
back
you have to
up
resolder
yet,
if it comes loose. Okay.
Yeah.
Oh, so Chuck, you've only been a ham for a few years?
I've only been a ham for about going on, this is my 4th year.
Man, the ham radio community is getting a great leader. We need more guys like you.
Oh, thank you.
To come in and then be the head of a club in 3-4 years, that's fantastic. That's fantastic. I mean, I've been ham for 50.
Oh, we've got hams that have been
51 years now.
Yeah, Doug, I think is our member with the longest time. Him or Don, I forget which one, but we're talking 60 plus years,
Wow.
70 years. So
well, that's really good. Yeah, 4 years and you're taking the lead. I couldn't lead my ham club. I'd be arguing too much.
Well, one of the things I brought in is, you know, I saw the hobby. I got into it for I'm an IT. So,
cool.
You know, I saw how the internet and ham kind of came together with DMR and Echo Link and things like that. So, you know, that kind of interested me. And I'm like, well, how does RF work? You know, and so that's what got me involved with it. And I jumped in with both feet. And basically, you know, I'm trying to get, you know, one of my personal things is, you know, how do we get the younger generation? Because I'm not a young puppy anymore. I'm 50 this year. But, you know,
you're younger than me.
I'm younger than a lot of people in the club. How about that? Less experience is the way I put it. I'm not quite as experienced. It's not age, it's experience. But
that's good. That's good. We need folks like you.
And you know, how do we get the less experienced on board? And our club is one of the few clubs. I mean, we have a hands-on training class before COVID, of course, where people get to actually, instead of just read the questions and learn it, our instructors actually have I think they might even have one of your antennas, or I at least brought mine in and showed them and taken it apart and showed them how it's put together and things like that. They have mock-up radio sessions to actually get people to talk, because mic fright is one of the biggest problems with ham radio, especially as a technician class. I run a Hamlet net for new hams to get on the air to get over that mic fright. So we've come up with some ways to kind of get more people
then when you
involved.
get these guys over mic fright, you can't get them to stop talking.
Sometimes you can't. I mean, I'm talking all the time.
So anyway, this antenna system here, we include all the connectors, great for emergencies, bring to emergency system, because they'll do Baofengs, they'll do BNC, the old ICOMs, and then we even include an adapter to do PL259.
Yep. And
then see, here's some other talks I give. How do you get gain out of a J-pole? It's not like a, it's not like the Slim Jim that we mentioned. No, you cannot get 6 dB just by soldering 2 tips together. It's a lot more complicated. We have a talk on that. Then we also have a talk on a tri-band, how you get tri-band out of it. So again, my talks are pretty filled until the end of the year. If you want to listen to it, just sign me up, but it's not until November now.
I might send you an email and we'll get you signed up for November.
Yeah. Just again, I only give 2 talks a month. I'm just too busy with school and other things.
Understood.
I only can commit to so much to this. And okay, among radios, I think for like tri-bands, I tell you, we give out a lot of these radios at our club meetings, prior to COVID, and I have them. People they would ask, well, what's a good tri-band radio? Well, these aren't bad. I've tried these. I got for $100, $110, 25 watts are fine. And then this handy talkie, the Baofeng one, it's called the ×3, which is the meter 224/40 version. It says 59. No, I've seen these go for 39. And if you're going to go buy your Baofeng, go buy a tri-band one. It works fine. It has everything that the regular dual band has, and also includes 220. And, these radios are fairly similar. Just one's marketed by BTEC and one's marketed by Radio Oddity. The Radio Oddity one tends to be a little cheaper in price, not quality. They're basically the same radio. But I've had mine pretty good intermod performance. I can put an antenna outside, and I would say it performs fairly well, matching up with the ICOMs. Here's another radio we worked on. At least I worked on back in 2012. It's called the GP5 by CountyCom. One of the first pure software-defined radios. We use a Silicon Labs chip, a DSP chip, 22-bit DSP. If you guys want a portable DSP radio, it does single sideband detection, CW and AM. It covers, basic ham bands and all that, and rock solid. Uses product detectors and single sideband filters that we wrote in the digital domain. But then you don't need a PC or anything like that. It works by itself. It's got a little audio chip in it. Well, it's got the Silicon Labs chip, which is really good, and it's got a Toshiba microcontroller. Normally, if you go to the CountyCom site, this is a contract they had, and they gave it to us to see whether we can build it. That's what we came up with. If you need them, we can get them for $65. They're normally $100 on their website. So anyway, that's the end of my talk. If you guys are interested in ordering, we had to raise prices because of after COVID, everything's gone up. All our materials have gone up. But you guys probably noticed this, and I try to explain to my students, the reason why it goes up is whatever you throw, and this is a good solution, don't get me wrong, but there is a consequence. You're giving to charity whether you like it or not. If you have the government print up $2.5 trillion of money, which is a good deal because people are starving, you got to hand them something. Basically, what it's saying, and I explain this because my students say, things are all going up. What are you going to do? I go, well, when you receive a check from the government, this COVID check or whatever, they printed out $2.5 trillion of it. We didn't make any more. They printed it. What it says is now you have more money circulating in the economy, but you haven't directly made more. You're just trying to keep people afloat. Well, who pays for that? You get inflation. It says that every time, well, I know In-N-Out Burger used to be, $3.50, $3.60. Now it's like, $2.50, $2.60. Now I went in the other day, it was like $3.20. Consider that extra 70 cents is the charity. That's what it's one way of looking at it. That's why things go up in price when you print money. And that economists will tell you that. Anyway, so we're in no rush. We have plenty of things to do now. but maybe in a month or so, Chuck, if you want, or whoever wants to take the lead, you can order. You guys could do a club order. The dual band bass is $32. We could also make that in commercial version for 152 to 157, and then 460 to 470. So I'll cover MERS. The commercial version covers MERS, some of Marine, and then GMRS, FRS. We do that in a roll-up also, same price, 32. So that's about $8 off our web price and about $12 off the eBay price, because eBay charges a commission.
Yeah.
And the tri-band is about $65. You can buy that direct. And then of course we have extra cables if you want them. And of course if you want the BNC, the PL259 connectors, an extra $250. Anyway, we'll circulate this. I'll send you guys the spreadsheet. And then if you want the radios, instead of 100, it's the $65. That's a really cool radio. We worked on that for a good 2 years, trying to write all the software, and we got a hold of the chip. That was really a fun project. In fact, one of our projects is that radio. We've made a companion single sideband transmitter. That was one of our the projects in one. Actually, it was in Ron Kwan's class and my class. And it was pretty cool. We made a single sideband matching transmitter board for it that they had to build. And in fact, we talk about that in the tri-band antenna talk. I'll show you some slides and the schematics for it. Okay, so that's the end of talk. How about questions? Now we're open for questions.
And really quick, Ed,
Sure.
yeah, if you'll send that to me, I'll make sure that, I'll talk to the club, see if anybody's interested. Maybe we'll get a group order together as well. And then I'll also hit you up in November for your next presentation.
Yeah, sure.
And I wanted the people to know, as a personal experience, when I bought Ed's tri-band 3 years ago, it does come with the PVC pipe, and it comes USPS. And unfortunately, Ed, I had contacted you and said, hey, the USPS destroyed my PVC pipe.
I did.
And it was cracked, everything else.
It happens.
And he actually gave me a refund, and I went out and bought a new piece of pipe and re-put it in myself, because it's just a 5-foot piece of pipe. The end caps were already there. I just had to put it back in the new one, and I was good to go. So I mean, you back your stuff as well, and I appreciate that.
Typically, I would say maybe 1 out of 20 gets destroyed by the post office, and I just no problem. I just send you another one. It's not a big deal. It's
like they sat on it or whatever. But
I think they use it as a javelin.
They might. I don't know, but I'll tell you, this antenna, like I said, was outside for almost 3 years straight. I pulled it out right before winter because I lost the connection on the bottom, got a little loose, so I resoldered it. But other than that, it's been a great antenna. And when you talk about tri-bands, I actually use the Anytone 578.
Oh, that's a good radio.
Tri-band, but it's also DMR. So I've got the best of all worlds, and that one is a good radio. And it's it's the $300 price point, but if you're looking for an end-all be-all, that's starting out, that's kind of a good radio if you can afford it. So.
Yeah, that is a very, very good radio. John Lee Martini reviewed it, and he says, "Oh, that's a really, really nice job they did on that."
I'm just waiting for the faceplate, the Bluetooth faceplate, because it doesn't have a detachable faceplate. But other than that, it's a great radio. We did have a couple questions in the chat.
Yeah, sure, questions. Go ahead.
There was one about the tower picture, asking about, do you need to keep the distance of greater than 10 feet because of all the antennas and everything like that? I think it was more of a kind of a funny, but on something like that, would you need to keep a farther distance with all those J poles and everything? On the very first picture with all the antennas.
That one, right?
The very first one.
This one.
No, that one right there. That one right there. No, back one, the other way. That one right there.
Right.
Yeah.
Yeah. So, ideally, this, when you go up in these towers, they're not ideal. They're just doing whatever they can fit in there. You should be at least, few wavelengths at least. Even a few wavelengths, you'll have it affected, especially if it's parallel. But what are you going to do in a tower like that? You have no choice.
Right.
It's not optimum at all.
So hopefully that helped answer.
Yeah. Yeah. I mean, the lucky guy is the guy on top right here, right?
But everybody can't be on top. Up there. And he paid a lot of money to be up there.
Big bucks. Yeah. Big bucks. That's right.
Yeah, we're actually, our antenna is set on top of the Justice Center, which is the police department here in Longmont. So we're fortunate enough to get a location up there, and they work pretty good. And we're looking at towers up in the mountains as well that we may eventually move a repeater to as well. So to get some more coverage in our area.
Yeah.
And then we had another question. So what kind of bandwidth I'm just reading them out of the chat. So what kind of bandwidth does this have on UHF, VHF to get an acceptable return loss SWR?
Reasonable. The bandwidth covers 2 meters, edges. If you're going to go with the edges, here's the trade-off. If you want a good high performance antenna, it's got to be high Q. If you want bandwidth, I got to give you a dummy load, right? Mm-hmm. So if you're an antenna designer, you know the trade-offs. So we try to keep it at the band edges below 2 to 1. I mean, when we ship these, we resonate 2 meters, 146. At UHF, we try to resonate about 446, 447. That's because, remember, you transmit between 445 and 450 for the inputs of the repeaters. So yes, it is difficult to achieve 10 megahertz of bandwidth at UHF. So we tend to bias it a little bit on the 445 to 460 or 450 region. And again, at resonance, you're fine. But as you go off at the edges, we try to keep it below 2 to 1. But it is hard because, again, if you want a decent performing antenna, it cannot be broadband. It's got to have high Q.
Right.
So yeah, I mean, it won't blow up your radio, but yeah, I have to say between 1.7 to 2 to 1 at the band edges, if you want the full bandwidth.
Okay.
The good news is on 220, the band's very narrow.
Yeah. And there's a 220 question here too, and I'll get to that in a second.
Sure.
It goes, what is the 2 meter, 70 centimeter performance of tri-band versus dual band? So you sacrifice performance for additional band?
No. There's no sacrifice. You have to remember the tri-band's a little taller though. We sneak it in. It's an extra of almost a foot taller.
Okay. Hopefully that answered the question for you, Brian.
No trade-off. The trade-off is it is taller by about a foot.
And this was just a comment. It said, J-poles do not need lightning protection. I'm glad to hear that. As a new ham, antennas and lightning are a worry area for me since I don't have any experience yet. So that's just a comment from a new ham. So glad to hear that yours doesn't need lightning protection.
Yeah.
That's always a discussion.
Let me make one thing clear. I don't like to call it a lightning arrestor or lightning protection. People say, oh, I'm going to buy myself a lightning arrestor. It does not arrest lightning, right? Boy, Chuck, if you and I can invent a lightning arrestor, we wouldn't have to work another day of our life, right?
I wish.
Yeah. There's nothing that can stop lightning. Insulator, I mean, lightning hits trees in the forest. They're not copper, they're not conductive. Anything, there's a pattern if it sticks out, nothing can stop. If lightning is going to hit your house, it's hitting your house. It's not going to ask questions. What a lightning arrestor does, really what it does is it doesn't arrest lightning. All it does is if there's a storm close by, if the antenna is open circuit, like in a dipole in a ground plane, you're going to induce like a transformer, right? You have to remember that lightning is 10 million volts. All it has to do is induce about 40 volts into your antenna. And if it goes down through your coax into your front end, most front ends will survive about 30 to 40 volts. That's about it. And it'll take out your front end. But then if you have a DC short, like in a J-pole, at least it will short it out. It won't go down. That's all it does. But it does not stop lightning. That nothing can do.
Okay. One person asked, as you speak about placing your antenna vertical versus horizontal, and then also asked the question, does anyone use 220? I know 220 is really light around here. There's a few people that do, but it's not super.
You know who uses
popular.
220? We're standard. We're standard 220 here for all the packet stuff because FEMA wanted it that way. And the reason why they wanted it that way was because they want to do their voice channels on 2 meters and 440 during a disaster. And if they put packet on there, like at an emergency operations center, boy, that packet goes off and you've got your 2 meter FM talking simplex or some handy talkie 5 miles away. It blanks it all out. So what they decided was, we're going to try to do as much packet on 220 as possible. And that works. So a lot of packet is on there. Even here in the Bay Area, a lot of packet.
Okay. Doug, hopefully that answers your question.
Vertical versus horizontal.
Oh.
Yeah.
Well, I mean, all our repeaters are on vertical, but if you're doing DX, it's horizontal. And yeah, this antenna will work horizontal. Just turn it horizontal. But most repeater work is vertical.
I had a ladder line several years ago, and it was horizontal, laying on top of a bookcase, and I had a terrible time getting into our repeater.
It would, yeah.
And somebody, one of the extra class operators said, "Doug, what's your orientation for the antenna?" And so I switched it from horizontal to vertical and improved things.
Yeah,
eventually the coiled up ladder line had a problem, and so I've replaced that with a really nice 11-foot 2-meter antenna outside.
Now you're fine with a 2-meter antenna outside vertically. I'm sure you're fine.
I know I am.
Yeah. Okay. Oh, good. Okay. Any more questions?
Yeah, there was another one that says from Raman, loaded coil antennas and mag loops are high Q. Are they higher efficiency than a low Q antenna?
Yes. In fact, a loop antenna is very high Q. It's very efficient for its size. Or if it wasn't high Q, it worked terrible. Have you ever know who's got one of these loop antennas? They actually work quite well for their size. And they have to be high Q. That's why they're, it's a really narrow band. You ever notice that you have to tune them? These loop antennas, I've played around with them. Oh, you got to tune them. They're very, very narrow band because they're very high Q. And could you make it not tunable? Yeah, put losses on it. Then it'll work lousy. Maybe they can add, does that answer it?
Does that help?
I mean,
who asked that
I actually
question?
use a super antenna MP1C with a loading coil on it. But for Christmas, I got an ICOM 705. Santa was very nice to me. So I was looking at the AL 705 mag loop and doing other research on other mag loops as well. And sort of comparing those with those, with like a 49-to-1 transformer and a 91 transformer that I built.
Oh, the loop would work better. The loop will win it hands down. But remember, the good ones have an automatic tuner, or you can tune it automatically because they're very high Q, very narrow bandwidth. But for their size, they're very efficient. Cool. It will win hands down. If you say, oh, what happens if I substitute this with a loading coil? No, it would be no comparison. No comparison.
Sweet. Thanks.
Yeah, we used to have a club member who was big into loops. He built his own. Built with the, I think it was Arduino as the controller and the whole 9 yards, did a presentation on it, and did a really nice job. And he moved out to Washington State, and I think now he's got a 50-foot tower and remote. He's still a member of the club and do a presentation, but all of his stuff's remote, so he has no RF going into his house. And it'd be interesting to see his setup now, and I'm trying to get him to present, so I think that'd be great.
Oh, that's pretty cool. Yeah, you ever notice that when you build loops, they always recommend, Raman, if you're listening, that capacitor is really important, right? Don't get a cheap capacitor. In fact, you get one of these Super Jennings vacuums. You have to. It's got to be really high Q. What I notice is, well, even the smallest resistance just kills you. So yeah, you can experiment with them, but you can just buy like an Alex loop. I've played around with Alex loops. Those are pretty good.
Yeah.
I mean, for what they are, right? I mean, is it going to match a dipole full size? Of course not. The math isn't there. If you work out all the math, no, it's not. But if you're going to build a small one, like 1/10 the wavelength for a small antenna, then it's got to be really high Q. Otherwise, it's worthless. Yeah. I've tried these. Boy, you'll be amazed. Just even the littlest thing you do to it, the performance just drops like a bucket of heat sinks. I mean, it's that bad. So you've got to be very careful. I mean, again, these loop guys like Alex, these guys, they've experimented. They spend their lifetime doing this. I don't, but they spend a lifetime. They've ironed out every little detail. But they're kind of fun. It is amazing, a little loop sometimes like that. If it's designed correctly, it's very narrow band, but you go up on top of a hill, it performs quite well. I've been impressed when I played with them.
Yeah, we have a few
other questions
in Colorado.
Sure.
I just wanted to say I've got your dual band roll up, and I really like it, man. It works well. I bought it from you about 1.5 years ago, I think.
Oh, good. Yeah. And it's good enough. The band, people ask you, do you need a balun? What I've noticed, and we've actually do on the air tests, with real spectrum analyzers, we couldn't tell the difference because our resonance is pretty good. People say, do you need a balun? I go, well, you need one if you're not resonating, because you don't want power to come back into your radio and blow up the radio. But in terms of it, the antenna operating better, the best antenna is ones that actually resonate. So I noticed that we can put ferrites in ours. It doesn't make any difference if you stay within the ham band. If you don't, sure, then you have to put some type of choke in there because you're not resonating. I mean, I'm just not a belief in RF choke balance. My belief is get the antenna working right. In most cases, if you need an RF choke balance, it's because your antenna isn't resonating. It's returning back power. And we've done this, we've experimented. Boy, if you have a mismatch, does that balun or ferrite choke help? It probably helps your radio so it doesn't burn up. Those things get hot enough where you can't even touch it. That means you have a terrible mismatch. Your RF is just burning up in those ferrites, which it should, you know, if it's mismatched, because you don't want it going back in your radio. No, I wanted to go into my antenna and radiate. So I tell folks, if you have to use a balun, there's probably a better way of doing it, at least for narrowband.
All right. We have one other question is, yes, John, I'll make the presentation available after tonight. And then receive loop antenna versus dipole or yagi.
Oh, so in receive, you're always better off with the highest, what's called the radar cross section, RCS. So the more bigger, as long as it's got to be matched, of course. The more intersection of a wave you have, the better receive you have. Now you'll get noise too, but you know I've seen these loops; they work well enough. Yeah. You know, my personal antenna on field day. If you ask that question, what does Ed Fong use on field day? And I've been doing this for 55 years. The best antenna I've noticed is get a resonant dipole that's resonant, and get it up as high as you can on each band. Those tend to work the best. For the simplicity and efficiency, they work the best. All these other ones are good. They're fun to play with. But if you want to make contacts, make sure that antenna is high up. Here we have redwood trees in California. So we use a vacuum thing we made up that shoots a tennis, or it's a capsule up with a fishing line, and then we pull up dipole antennas up on these redwood trees. Get them up 100 feet. It is amazing what you can do. Absolutely amazing. And we go QRP and we make really good contacts. So that's my choice. The dipole must be high up in a good location.
Yeah, we're high already because we're roughly around 5,000 feet in this area, 4,900 give or take. So we already have an advantage because we're close to the mountains and we're already high altitude. Part of the problem we have in Colorado and a lot of hams, and this is discussions that a lot of hams have had in different nets, is, you know, a lot of us have HOAs, homeowner associations, and they don't allow towers and things like that. So, you know, putting a dipole out there sometimes is really hard. You know, your antenna is good enough that, you know, technically you can put it on the edge of their porch and it works. You know, and you can't see it from the front. I actually have yours on a mast. I've got those old Army pole. And
yeah,
I've got
those are good.
Several masts. Yeah. And this way, well, my philosophy is better to ask for forgiveness than permission. So, you know, my thing is, one, I never said anything. And if they did, I'd say, well, it's temporary. It's a mast. I can take it down anytime. I'm just experimenting, you know, or something like that. But luckily they haven't said anything, because I also have the octopus dipole system for my HF antenna, along with a dipole string across my backyard, which isn't very pretty, but it's functional. And it seems to work.
Yeah. So Chuck, the question I had, or I have a pretty good explanation. Your high up is one thing. Above ground, you know, the ground soil is another. So you got to get your antenna above the ground, because it's got to be at least a half wave above. Otherwise, the signal radiates into the sky, right? Right. Then you're in a NIVIS, you know, situation, NVIS situation. So you've got to get it up at least a half, at least a half wave up above ground of what you're operating. Then the antenna, the dipole antenna you use, becomes more efficient. Otherwise, yeah, it's a tough fight. And I've been doing this for years and years and years. And yep, just trying to you got to get that dipole high up on HF, and it makes contacts.
Yeah. Another question was, how difficult is it to tune the dual band antenna for non-experienced antenna building hams, say for a club build project?
Very tough. Yeah, all our materials are special made. Even our twin lead is special ordered from us. It's very tough. But what I do tell people, if they want to do this, I can send you, well, you buy a sample from us, or somebody might have a sample, and I'll send you the exact material. So all you have to do is copy it. Then it makes a good club project. If I send you the RG174 we use, if I send you the twin lead we use, then yes, you can duplicate it. But otherwise, it's lots of fun. If you want to spend weeks and weeks of trying to find the right dimensions. See, it's not the lambda, the wavelength. Oh, we know there's a quarter, half wavelength. It's a matter of what is a half wavelength in this material? That's the hard part, because as the material changes, the diameter, the insulation changes, it varies, quarter inch here, half inch there. You've got to fine tune it. And the question is, if you got to make 3 or 4 things kind of work in concert, that's tough. Then you have to measure it with good, stable equipment. Again, I've had very good success with clubs building it, but I just send them the materials. Like if you need 100 feet of that twin lead, I can just send it to you because we have it all special made.
Good to know. So if somebody wants to put that together,
yes,
go for it, because I don't have time.
No, I've had very good success where they have a sample working that's made from us, and then I send them, 100 feet of this, 100 feet of that, and they cut it. Yes, they can get it to work.
One other comment, great job, Ed. Another comment was the G5RV antenna is a compromise antenna, but portable and versatile. Another question was G5RV versus separate single band dipoles.
Oh, second single band dipole, hands down, hands down. Hey, this is the experiment we did. This is my opinion. G5RV or a good wire tuner. The good wire tuner might cost you $100. Pick it up used on eBay or something. We couldn't tell the difference. And a G5RV, it has to be in the clear, the way the matching and everything works. I would say this: if you want a simple antenna to perform well, not excellent, well, we've done this on field day. This is our second best antenna. A dipole with twin lead coming down into a wire tuner. That seems to work okay too. If you can't afford multi-band dipoles. That'll be our second choice.
That's why I like that octopus system. It's a 4-band dipole system and it works great.
Right. Those are actual resonant dipoles.
Yeah.
Yeah,
it's a little tricky to tune them, especially when you get them up at 20 feet above the ground to try to tune them. But other than that,
you have to bring it back down, tune it,
yeah,
put it back up.
Yeah, exactly. And then of course that affects it every time you move it up and down.
It affects it, right? Because as you bring it down, it forms capacitance with the earth. So if you have it tuned on the ground, it'll always be lower in frequency. And when you start lifting it up in the clear, the resonance starts going up, right? Because you don't have the capacitance with the ground. So, okay.
Well, any other questions for Ed? Ed,
sure.
Thank you very much, sir. Great presentation.
No rush on the antennas, by the way. We're really swamped always here. And plus I've got my classes I'm teaching and teaching it through. Yeah, it's interesting. I think my students should get 30% of their refund. I mean, they're not getting the full course by seeing me on Zoom once a week or twice a week.
Do you do hands-on in your courses? Like you'll pass the ladder line around and people feel the material?
I did.
Like okay. So you're kind of like our instructors as well.
Yeah, I require everyone to buy one. I said, you buy a textbook, you buy a network analyzer in my class. It's a signal generator. I'll show you how to tune a duplexer, antennas, signal generator. A lot harder to do, like what we're doing now. I mean, it's a lot easier. In my class, I'll have six to 10 graduate students. We all hold one up, and it's like a lab. You guys try this, calibrate it and all that. It's a lot slower if you're doing it on Zoom.
Yeah. Oh, yeah. And somebody had a comment. Dick, are you on KE0VT? You had a comment? Go ahead, sir.
Go ahead.
I do. I bought your dual bander about 5 months ago. My call at that time was in 0AJM, and I got a vanity call since, but I have it in the attic. And I asked when I bought it, how would it work? And you weren't certain, but I want to let you know it's working great. It's up about 20 feet above ground, not quite, maybe more like 15. But a little dual bander just works great. And I work.
Oh, good. Oh, very good.
Yeah, because I mounted it for him. That's why it works so good.
Again, if it's not in the clear, what you'll find, the first thing you notice is my antenna in the clear enough? Well, when we tune the antenna, it's in the clear. If you see that the resonant frequency is lower than we claim, because we try to tune them at 2 meters, 146 megahertz. And let's say all of a sudden, in your case, it resonates at 145.5. That means your objects are coming into play. It's forming capacitance to the antenna.
Yeah.
That's how you know how clear you are. Because if in our antennas, if you buy it from us, if it's way up in the clear, it should tune or resonate at 146.
Now, I'm mostly on 450 with it, but it just works great. I'm very happy.
Have you measured, where does it resonate at?
I don't have the foggiest notion. I don't have any way to measure it.
Okay, well, if it works, don't touch it. That's the other thing engineers think. If it works, don't touch it. Because
it ain't broke, don't fix it.
Yeah, because the only way place it can go is it breaks.
Yeah. Well, the one thing we mounted that, I made sure it was on a stud without anything else really connected to the stud other than at the bottom and the top.
Oh, good. Okay. Okay.
So the only interference really would be any potentially metal interference would be, at the very top for the shingles of the roof.
Yeah, the antenna is in the clear, right? You mounted it on a stud on the bottom to anchor it, but the antenna is open.
Well, it's on the edge of the stud.
It's on the edge of the stud.
So it basically is strapped to the edge to the stud. So the stud goes, north south, up and down, and it's just on the side of it, and then we have the coax running down. And then
so it is against the stud then?
Yeah, correct.
That's not good.
It works good though.
Yeah, I mean it might work, but it's not good because
right.
You say it's not conducting. No, the stud doesn't conduct at DC. It creates what's called a velocity factor at AC, at the signal level.
Okay.
It should be in the clear. Again, you'll notice this, put a network analyzer on it, and if the resonant frequency is lower than what we expected at, that's caused by the stud putting capacitance against the antenna.
Well, Dick, maybe I'll come over and I'll move it in between the studs at some point.
Right. Just hang it. If you're in the attic, just hang it.
We might do that next time I come over.
But again, if it ain't broke, don't fix it.
He can hit the repeaters. I think he's a happy camper.
Yeah, if you're a happy camper, because it only can go one way and it can break.
Right.
Well, it can be improved, I guess. Anyway, okay.
A lot of other comments. Thank you very much, Ed.
You're very welcome.
Talk and presentation.
Yeah, and then I'll send you this presentation if you guys want to distribute it.
That'd be great. Thank you very much. I appreciate that.
And I'll send you the spreadsheet, and then we'll schedule you in for November.
Yeah, I'll send you an email and as a reminder to do the second one in November and go from there. And again, if anybody's looking for a reasonable antenna to get started as a new ham, Ed's antennas are I recommend to everybody because
do it as a group purchase because you save about $8.
Right. So what is the minimum for that group purchase?
I don't care. It's a club, right? And
okay, as long as it's from the club, you'll
yeah, it's fine.
Okay.
I'm going to sign off here because I'm getting hungry. You guys already had dinner?
Oh, we had dinner and drinks already. It's almost bedtime for us.
We're only 1 hour difference.
I know.
Right.
For some of us, anyways.
Hey, I hate to say this, man. My wife thinks I'm nuts. I got to stay up till like 1 or 2 o'clock in the morning. Every night between this side job of selling antennas and after I get through all my schoolwork and the good news. See, actually, here's a secret. Good news. I actually save time with COVID because I don't have to drive to work.
That's true, especially out there. Driving stinks.
Yeah, but I feel sorry for my students. They're definitely not getting as much as they should. Nothing like a live instructor, looking at your lab work and all that. But for me, I think I end up with at least an extra hour and a half of my day. I don't have to drive anywhere. Plus, I don't have to get up quickly, take a shower, and get on clothes. And hey, I can wake up at 8:30, just put on some sweats, go to my room here. See, this is our workroom. You're seeing my workroom right here. Come on in, turn on my computer, and I'm here. So it's very efficient from my point of view. But in terms of productivity, no, we don't get the same productivity.
Yeah, our instructors for teaching the tech in general and extra class is really missing the hands-on.
Yeah,
We haven't even done it over Zoom because they've had some other issues, but we're looking to try to do that again because a lot of people really enjoy those classes and get a lot more, hands-on, touchy feel, and they get a lot more out of it than just reading a book and answering.
It's a lot more fun.
Yeah. Oh, definitely. I've taken the general I've taken all 3 of them with our instructors. I just haven't taken the extra test yet. And it's definitely for me, I'm a hands-on person, so I like to see the stuff. And I mean, we're talking Brian, who's one of our instructors, AF0W, who's actually on the call this evening. You know, he's got resistors, capacitors. He hands those things. He's got full, I think he's got an amplifier he's shown, radios. So, you know, it's a real hands-on for a ham class. So I think a lot of people enjoy it. And it's
yeah.
a big benefit for
Yeah,
people.
when you can see an antenna, right? See a resistor, see a network analyzer. It's just much more fun. But hey, hopefully it's going to be all over in a few months. So are you guys getting shots yet? Are the shots arriving?
They're arriving. I believe right now, again, it's 70 and over and healthcare workers.
Yeah. I am now knowing people that have gotten the shot. So eventually it'll come to me.
I've gotten both doses.
Oh, you have?
Yeah, I'm a pharmacist at a hospital. I didn't have any problems. We had probably out of about 100 people in my department that I know that got it, we've had maybe 6 that had reactions to it. And mostly it was just fever and chills, stuff like that for like 18 to 24 hours.
Yeah, they say expect that.
Yeah, and then we had one guy that had a maybe 72 hours, but other than that, everybody's fine. Other than sore arm.
No, it's coming. I predict the university is predicting by fall we're going to have back classes. Not summer will be a little aggressive, but by fall they're planning right now. Unless anything else comes up, we're going to be back in class.
Yeah, I know CU up here in Boulder had classes and then had in-person classes, and then they also quarantined probably, you know, hundreds of people because of that. So they kind of learned from experience that we're not going to do this again. So
yeah, I mean, you know what I don't like in the news? People, these parents are saying, show me evidence that we can't have class, or these restaurant owners. You don't have to. There's plenty of evidence.
Yeah.
When you get together with people not in your group and you let down a mask, whatever, it spreads.
Oh yeah, or potentially could spread
spreads.
one of the So
you got time for one more quick question?
Yep, sure.
Why couldn't you, for lightning protection, just use an RF choke to ground?
RF choke does not prevent lightning.
Yeah, but it'll bleed the charge off.
Yeah, only with DC. Yeah, you could.
Well, that's what the DC charge is.
Yeah. You can bleed it to ground, but it's the same thing with here's the ground, which is a shield, and it's in a J-pole design. It's a dead short. You don't need.
Yeah, no, I'm talking about in general.
In general.
Yeah, for any antenna.
Oh, just put a big choke. Yeah, you can do that. Sure.
Yeah, an RF choke to bleed the charge.
Yeah, an RF choke. Sure. And going to ground. Yeah, because it will be a high impedance at AC, but low impedance at DC. Sure, you can do that.
Okay, listen, I've really enjoyed your talk. It's very,
you're welcome.
Very informative. May I offer a suggestion?
Sure.
For those of us who have a limited capability with seeing things very well, how about making your pointer black instead of white?
Oh, you mean reverse it?
When you're moving your pointer around.
Is there a way of doing that?
yeah, within Zoom, I think you can change your pointer color. Or well, you did it through PowerPoint. Sorry. Yeah, check in PowerPoint, but I believe you can do that. You can change your pointer color.
No, but this cursor here is a Zoom cursor.
Oh, Zoom cursor?
Right?
Okay. Oh, well, yeah, when you present, I think you can in Zoom. Most of them offer that now because there's a lot of, especially with Zoom and websites and things like that, are following ADA, Americans with Disabilities Act rules, and with like for screen readers, you have to have some type of text in there for pictures, or they know what it is.
Let me look into that. So can you see my cursor now? I'm not sharing.
You're not sharing.
Oh, hang on here. Let me try this. I've got to share. Let's go back. Share. And I am here.
There you go.
Okay, so you see my cursor as a white?
Yeah, I see it as white.
Yeah, it's just an outlined white.
Right. So that's a Zoom cursor, yes. Right, you see me moving it around?
Yep.
Yeah, but you need to make it black so it's easier to follow.
Right. Okay, let me look into that. Yeah, that's a good idea. Yeah, black, you would clearly see it much better.
Much better.
Yeah.
Thank you.
So that's one thing I like about hams. We have, it doesn't matter who you are, you can be a ham. whether you have, you know, some disability or whatever. I mean, it's great. I love this hobby and the people that are in it. So,
well, I've concluded this after my 55 years. There are more hams of any other hobby that I know of that it welcomes more people from different careers and different educational levels than any other hobby I know of.
oh yeah.
We've got, in our group, we've got dentists, doctors, engineers, school teachers, housewives, right? Hey, if you're interested in radio, come join us. And I tell you what, our other big attraction, our biggest attraction in our club was we offer free dinners at our club, you know, when we have regular club meetings.
I was bringing snacks and
Oh,
coffee.
we have it catered. We have it catered between China, let's see, Costco Pizza is one, that one you'll be familiar with. But this Italian restaurant helps us out. This Mexican restaurant helps us out. And this Chinese restaurant helps us out.
Oh, I wish I had the space to do that.
No, no, when we meet at a school, we meet at a school.
Okay, yeah. So you have a little bit more space to spread out.
Yes, and it isn't that expensive. We usually get about 50, 60 folks and maybe $250 to $300 per meeting.
Yeah.
For us, it's not that bad because we make a lot of our money at our flea market. We don't have it this year, but
we do too.
We pull in about little over $3,000 every time we run the flea market.
Oh, okay.
Because we charge $25 a selling spot.
Oh, okay, yeah, you're a little bit more expensive than what we charge. And
well, what do you guys charge?
We're between 10. I think we charge between $17 and $20 a table.
Oh, okay, yeah. So we charge 25.
Yeah.
And we have 150 tables usually. So we have a pretty big swap meet here. So we'll roll in about $3,000.
Yeah, our one of the problems we have here, and Joe, who's on this call as well, he's the board president for Northern Colorado Amateur Radio Club. Is we have a lot of clubs here, and we in the Colorado area from Denver north, and we all have, you know, ham fests, flea markets, whatever, and sometimes it's competition depending on when you have it. You know, so it sometimes somebody will do one, not the other, and things like that. But it's a lot of fun. We didn't have ours last year. Probably won't have it this year either. But
yeah, we won't have it this year. But when it starts back up again so we meet once a month, and we'll pull in a little over 3,000 every time.
Oh, okay. So you have a swap meet once a month?
Yes, we meet at
really?
Fry's Electronics parking lot.
Really? Oh, cool. That's a great idea.
And you know, the thing is, we arrange it's good for your business. It's good for our business. Don't you like your parking lot full with people?
Yeah, we don't have Fry's here, unfortunately, in Colorado. So
yeah, so it's kind of mutual. So Saturday is the second Saturday every month is a big event at Fry's. With food concessions. Think about.
Yeah, our biggest thing, we do have a ham radio outlet, but it's in downtown Denver, so it's a, you know.
Oh yeah, right. You get the Denver one. Yeah.
Yeah, but it's about a 35-mile hike and takes almost an hour to get there because of traffic. So.
Oh, okay. Yeah, so I do a lot of work with ham radio outlet. They carried our antennas for a while, but I could not make it at the volumes they wanted.
Yeah.
No way. 14 stores, they were selling. We just couldn't keep up. So it was a good mutual separation. But I do order a lot of equipment from our prizes that come from HROs. We're in good relationship with them.
Yeah, I do too. Too much sometimes.
They're good. So, they're good folks. They really try hard. Anyway, I got to get some dinner. I'm getting hungry, guys.
And one other quick question: do you guys have a raffle at your?
Absolutely.
Okay.
That's how we raise money. Another way of raising money.
Somebody asked that question, so.
We give a radio, you know, like so we give like a quad band, one of those mobiles, as a grand prize usually. And what we have is the first prize. We usually have a selection, like 3 or 4, because quite often what we do is, and yeah, by the way, I'm the prize chairman who also of 2 of our clubs. No, 3 of our clubs. You don't want one prize because you want to sell tickets.
Right.
You say, here's first prize, your choice, because otherwise people say, I don't need a ticket. I already have one of those. Again, but do you have one of these? Do you have one of these? So you don't want them to make excuses. I don't need to buy a ticket because I have all these. So he said, if you win, you get a choice of this. And then once a year, we give a big radio like this. This last year, we gave 7,300. So ham radio outlet will give you, if you're in good relationships with them, they will give you the 7,300 for $800.
Yeah, we usually get our stuff from them as well, and they usually get us a deal. So we work with the one in Denver. They know about us because, again, we're the only club that I know of that has a hands-on training class. So they really push our classes for us as well. We've had
Yeah,
people,
yeah, that's good.
we've had people drive 30 plus miles to come to the classes, and it's a multiple day classes during the week and weekend.
Wow,
So
that's pretty nice. Yeah, that's
Yeah.
good. That's good. Yeah. So ham radio outlet again. Maybe I shouldn't tell you this. Yeah, but they basically the last time it was, and then we're tax exempt because they go through
Right.
my business. So $800 for 7,300. And you know what we ended up doing? We sold more tickets than what
Oh,
it
yeah.
cost the radio. We
Oh,
actually
yeah.
made money on it.
7300s are popular. Everybody loves them.
It is the for what it is, it's an excellent radio, very well thought out by Icon.
Definitely.
That the other radio that's also very good for the same price range is the Yaesu 991.
Mhm.
The 991 is an HF, but it doesn't have all the fancy features, but it has VHF, UHF built in for about the same price. HRLs would give it to you about the same price. So, anyway, I got to go. I'm getting hungry.
Right.
We'll see
Thank you,
guys
Ed.
later.
Go have dinner.
Take care.
We appreciate it. We'll
You
talk
betcha.
again.
You guys are very welcome.
Thank you.
Take care.
Thank you.
Does anybody in the club have anything else they want to bring up or discussions or anything? Questions, comments, concerns?
I have 2 of his antennas.
Yeah, I do too. Well, I've got one. I've got the tri-band, and of course the club's got the roll-up J-pole that I'm getting ready to play with now as well on the Go box. So one of the things, I've just so that everybody here who's club members, one of the things I've been trying to do is trying to get more people like Ed who are outside of the Colorado area to come talk to us, because I think it's good to see, other people. Ed, of course, this is antennas, but we've had, there's authors out there that's written books on other things and talked about other things. So one of the things I'm trying to do is get more people that maybe you've heard of, but you would like to meet in person on a presentation like this, or like to see as a guest speaker who's normally not, maybe from the Colorado area or something like that. So that's one of the things I'm trying to do more this year. And we'll see if we can get more talks like Ed. He's offered to come again in November, who is not, maybe a household name, but somebody, to you maybe famous that you'd like to meet as well because of what he does and things like that. So, we're thinking of ideas of kind of outside the box type ideas for presentations as well. So hopefully everybody enjoyed it, and we'll see what we can do for February and the rest of the months. And again, if you know somebody that you can talk into presenting to the club, by all means, please let me know. We're always looking for guest speakers for the club as well. Anything else? And don't forget the net tomorrow at 8 p.m. Jerry's on. Or if you'd like to run the net tomorrow, I'm sure Jerry would be more than happy to let you run it as well. Right, Jerry? He's quiet. Do what, Dick?
Say I have the announcement for you.
Yeah, go ahead.
That is that I got word from the county that fairgrounds are closed through March 31st.
Okay, yeah.
That's pretty much going to kill our date of the 4th. But they're not going to let us know until mid-March whether that they'd even be open. So at the very best, we'll have to postpone it and probably not have it this year again, looks like. But a little bit depends on how many vaccines that they're able to get out here. So we'll find out, and I'll try to keep everybody informed as to what's going on there.
Thank you, sir. Yeah, I brought that up earlier in the meeting that that was happening. So again, it's still up in the air to see what happens.
Yeah,
all right.
one other thing. I see that Craig, KF0CEQ, is with us tonight. He checked into the Hamlet net, and he'd been a ham all of about 4 hours, if I'm correct. Yeah, but look at that big smile. So I'm very happy to see you here at the club meeting, Craig, and hope you'll keep checking into the Tuesday net and Thursday one as well, sir.
Yeah, we like to see our new hams join us, so we do appreciate that. And he was on a Hamlet net last night as well. So, He was mobile last night.
He got his license 4 hours before debt. He's really excited to be on, and so that excited me and everybody else too, I think.
Yep. All right. Again, thank you, everybody. If you'd like to stay and chat, I'll keep Zoom open for a little while. If not, you're more than welcome to drop, and we'll talk to hopefully most of you tomorrow night as well on the Thursday night net. Otherwise, again, you know how to contact me if you have any questions, comments, concerns, complaints. I'll listen to them.
Thank you.
Thank you.
Bye-bye.
Yeah.
All right.
Thanks, guys. It was great seeing you.
Hey, Mike. W0KKI.
Yes.
Were you able to play with that anymore before the meeting? Your Pi?
A little bit.
Okay.
I sent a couple more things via 2 meter, and sent some things to my email that way. So that's nice. That packet's definitely functioning and working. I toyed around with a couple of the other things too. So we'll see. I mean, it's definitely functioning, which I think that's just because you were on the computer with me.
I told you it's my magnetic personality, man. I make things work.
So, hey, I updated the Google sheet.
Yes.
With
Okay.
the guy that just tweeted me.
Cool.
And then would we want like a Navy SEAL to do a speech of some sort?
I'll take whoever. I mean, it's your guy. I mean, it's the club. Let's, was he a communications guy or?
No, I have no idea.
Okay. I mean, it doesn't necessarily have to be about ham radio, but I mean,
right.
There's things that pique interest, but again, he probably used some type of radio to communicate with his buddies.
Probably.
They don't necessarily have to be licensed for it, or their military pays for the frequencies, but if you talk something like that as well, I mean, that's, I'm game for just about anything. I was going to have I was trying to get a Falconeer was supposed to come in last year, talk about raptors and radio beacons and stuff like that, how they track their birds with radios, but it didn't happen. So
I'm going to reach out to a couple folks in Team Rubicon too.
Okay. I think that would,
but not
Team Rubicon in general would be a good conversation.
Yeah. And then also the gentleman that is for the Colorado, Wyoming Red Cross, that's in charge of Colorado, Wyoming Red Cross. Okay. I'm going to reach out to him. He manages all their ham radio stuff. So like when they do, like disaster and stuff, and they deploy radios and things at the shelters. So I'm sure he's got some kind of presentation or something.
And there's been several Red Cross WinLink exercises going on like once a quarter. So that may be a good.
He's the one that coordinates all that stuff. Yeah. So he's a good friend of my wife. So
that'd be great.
I'm gonna reach out to him. So
because I know Jerry would attend that one because it has to do with WinLink, and I know Jerry's big on WinLink. So I see he's still on, so that's why I'm mentioning that.
So, okay, cool. Well, I'll let you know how those things go, and I'll keep that sheet up to date. If I get a definite booking, I'll shoot you an email. And
I see you put Ed in there for tonight. Thank you very much. Appreciate that. But yeah, let me know if you get a definite booking. I'm still trying to. I haven't had time to sit down and try to contact people. Unfortunately, I've been busy this week. That's why I still don't have the antenna marked and things like that. So, and you did say you did get yours marked, right? Or no?
No.
You just
not at all.
You just kind of measured it and played with it and see if it would actually tune at that range.
Yep. Okay. I used that sheet that I sent you, and I measured from the top, and I popped it down to, it's sitting at 40 meters. And then what I did was I attached it to the VNA, which is 200 plus feet away.
Mm-hmm.
And I put a remote camera on it. And then I go out in the backyard with my phone so I can see the camera. And then I just play with the collar to get it to tune.
Well, I'm getting a, I told you about this IC 1300 or whatever it is. It's kind of like a nano VNA, but it sends tones and everything else. And it's supposed to do pretty much, I think it's 0.1 to 3000 megahertz, something like that. I forget what it is. Actually, let me bring it up really quick and I'll tell you. So it does pretty much every ham band I can think of. So what I'm thinking about doing is maybe trying it to tune it with it. Then I don't even need a radio and I can be outside and just attach a 50-foot cable to it and, you know, be done with it. It's called a mini 1300 LCD 0.1 to 1300 megahertz HF, VHF, UHF antenna SWR antenna analyzer meter tester. That's a mouthful.
Nice. Yeah.
And it was only $175.
That's not bad.
No, and it's got, and on the screen when you look at it, it's got a for measurements, it's got like a little touch buttons for different things. And under measurements, it has single frequency, frequency sweep, multi SWR, tune SWR, and S21 gain. Under tools, it's got fine frequency, quartz data, TDR mode, LC meter, DSP. Under settings and signal generator, it's got configuration, managed snapshot, USB HF reader, RF generator, and a Whisper FT8 JT65.
Nice.
Signal generator. So. So basically what I plan on doing is basically, you know, once I get it tuned, you know, click on Whisper, let it go ahead and send it out on the different bands and see if I get anybody that hears me, and then I'm done. You know, that's basically in one little tool for $175 instead of dragging the radio out.
Yeah. Yeah, that's not bad.
Yeah. I'll let you know how it works and see how it does, because it's something else that people might be interested in. And I mean, a little bit more than a nano, but it looks like it does a little bit more than the NVA as well.
Yeah.
It comes with all the different connections.
Right.
So, yep, it should be here. I'm hoping by Saturday. Actually, it's only come from Kentucky and it's already in the mail system. So.
Well, cool. You know, worst case scenario, get to play with it on the 30th if the weather permits. So.
Yep.
Okay.
We'll see. Thank you very much, sir. Have a great evening, Jerry.
Yep.
Oh, Jerry disappeared. So.
Talk to you later.
All right. 73 surf later. Bye.
See ya. Bye.
Thanks for the link, Mark.
Oh, you're welcome. Thanks for the package today. See?
Oh, you got it?
Yeah,
Cool.
I've got it on and all of
There
that.
it is, huh?
Yeah, I figured I'd better.
Getting extra brownie points for wearing that.
Well, yeah.
So you got one to wear and you got an extra now.
Yeah, well, it's, you know, I'll have to wear it proud.
So Mike sent an email out. I didn't understand the topic. POTC.
I'll put my chair on the way here.
I'm gonna be right back. Hey, Mark.
Yes.
What's the name of your network?
It's like something Netgear.
95 5G?
Yeah.
Okay.
Chuck, we have a Kim on board. Do you know a Kim?
Yeah, I keep asking for Kim to put call sign in, but I don't see anything. I didn't hear anything, so I don't know.
Can you hear us, Kim?
But I am having some technical difficulties.
Oh, there we hear you.
Very low audio.
And then Doug just called me. He had problems getting on, so.
I'm here. I think I'm ready to go.
Okay.
Get a drink here.
Well, good evening and welcome, or for you, it's early evening.
To be on here.
Eberhard one. I don't
So-
remember if it's capital or lowercase.
No, it was lowercase.
Yeah. So, Ed, we'll start a little bit after 7 with the presentation.
ARDD.
Oh, sure. Go ahead.
Between 7 and a little before we do, just club business and things like that from the board and updates and stuff like that.
Go ahead.
And I did make you a presenter, so you are a co-host, so you can do whatever you need to do on the Zoom meeting as well.
Yeah, go ahead. Oh, no, do whatever. Hey, Joe, I like your background there. KD0TYU.
And then, yeah, like a number 1 and then.
At the
There's
end.
a number one there, huh?
Okay. I am going.
Okay, go ahead. I'm going to mute this.
I'm going to ask everybody to mute if they would, please. Make it a little bit easier to run the meeting. We're all adults, so I don't like muting everybody myself. So, and I know these meetings tend to be noisy on occasions because everybody's got stuff going on in the backgrounds and stuff like that. So, I would appreciate it, especially during the presentation. But of course, you're welcome to ask questions as well and unmute yourself during that time. Welcome everybody to the new year